question 6, you've got a little graph here, y equals ln x over x. And the first thing we've got to do is find out the coordinates of A. Well, and we can see it's crossing the x-axis here, so the y value equals 0. So let's just write 0 equals ln x over x and find out what x is. Times both sides by x, so we get 0 equals ln x. So e to the 0 and e to the 0 is 1. So the x value is 1. And unlike the question earlier in the exam, just writing x equals 1 doesn't get you the mark, because it says state the coordinates of A. So they actually need 1, 0 as the answer there. Now for 5 marks in the next bit, we've got to find the stationary point, the bit at the top there. So I've already started setting this up. I'm trying to differentiate y equals ln x over x. And the rule we're going to be using, of course, is a quotient rule. So u equals the top bit, v equals the bottom bit, differentiate this, differentiate this. And dy by dx is v du dx, those two things times together, minus u dv dx, those two things times together, all over v squared. Of course, these two just cancel out, so we get 1 minus ln x over x squared. Now at the stationary point, we actually want this thing to equal 0. So we want 1 minus ln x over x squared to equal 0. Worth writing this and not just sticking sort of equals 0 on the end there. That doesn't make sense. Times both sides by x squared. So ln x equals 1. And so x is equal to e to the power of 1. Not quite finished, because again it does say the coordinates. So I've got that the x value is e. I need to find out what the y value is as well. Go back up here. So I get the ln of e divided by e. The ln of e is 1. So we get 1 over e. So it's at that maximum point there at e and 1 over e. Final bit says find the exact value to the gradient of the normal at the point when x equals e to the power of 3. So we've got what the gradient is. Sorry, this is getting a mess, but there's the gradient there. And let's scroll down a little bit more. So at x equals e to the 3, dy by dx is going to be equal to 1 minus the ln of e to the 3 all over e to the 3 squared. 1 minus the ln of e to the 3, well that's just 1 minus 3, isn't it? All over e to the power of 6. So I've got minus 2 over e to the power of 6. Remember that question said that we wanted the normal? And so the normal, we do the negative reciprocal of that. So it's e to the power of 6 divided by 2. Or half e to the power of 6.